All right, so let's get started. So before we went on spring break, we left off at this portion. So we started doing disjoint events, and disjoint event and mutually exclusive event are the same thing. So if I say disjoint or mutually exclusive, yes, no, I'm talking about the same um, definition. So whenever we have a disjoint or a mutually exclusive event, pretty much what it means that if we have a single pull or a single selection, if they're mutually exclusive, that means either one event's gonna happen or the other event's gonna happen. But is it possible for both events to happen in a single pull or a single selection? So some example of mutually exclusive. So if you know about sports, you could either win or you could lose, but it's impossible for a team like to win and to lose. Another example, say like if you're doing a car could either be a Honda or it could be a Toyota, but it's impossible for a car to be a Honda and a Toyota. So whenever we're talking about mutually exclusive event, it is saying that both events cannot occur at the same time. Either one event's gonna happen or the other event's gonna happen, but it's not possible for both events to happen at the same time. And that's why we have this visual right here. So if you look at it, either A will happen or B will happen. But it's impossible for both of those events to occur at the same time because they don't have any overlap. So if I want to find the probability of A or B occurring, all I have to do is get the probability of A and add it to the probability of B. All right. Any questions in regard to that so far? All right, cool. So let's keep going. All right. So for the first one, it says the first digit of a number in a legitimate financial record often follow a model known as Benford law. Call the first digit of a randomly chosen record X. Benford law gives the following probability model for X. So it's telling us that the first digit will be 1. It has a 0.301 chance of occurring. The first number being 2, 0.176. So the first thing what we want to do is show that this is a legitimate probability model. So the way that we show this is a legitimate probability model is by checking these two conditions. So we want to check the condition that P of X is less than or equal to 1, but P of X has to be less than or equal to 0. And we also want to check to see if the summation of P of X is equal to 1. So those are the two conditions we want to check for. All right. So let's go ahead and let's first check this one. So if you look at all of the probability, do you have any probability bigger than 1 or smaller than 0? So is any of the probability bigger than 1? Cool. What about is any of the probability smaller than 0? If you want, you can put it on the chat. All right. So since we don't have any probability bigger than 1 or less than 0, this checks out. So the next thing we're going to go ahead and do, we're going to go ahead and get all of these numbers, and we're gonna just add them. So we're gonna add all of these numbers and see does it add up to 1. So I'm gonna do that in class calc. So let me share that screen with you. So let's go ahead and just start adding. So 0.301 added to 0.176. Add that to 0.125 plus 0.097 plus 0.079 plus 0.067 plus 0.058 plus 0.054 or 51, and then plus 0.046. So if you look at it, when you add all of those numbers up, it add up to 1. So that means that the second condition also passed. So we could say this is a probability distribution or probability model. So this one passes. So we'll say this is a probability model. All right, so that's it for A. So up next, we're gonna go ahead and we're gonna go ahead and find B. So for B, we're gonna say probability. If you look at it, it says find the probability that the first digit for the chosen number is a 3 or a 7. So first thing you kind of have to notice that this is a mutually exclusive event. The reason why it's a mutually exclusive event because the number is either going to be 3 or the number is going to be 7. But it's impossible for the first number to be a 3 and a 7 at the same time. So that's why the mutually exclusive event. So we're going to say 3 or 7. So we're going to get the probability that it's 3 and add it to the probability that it is a 7. So going back to this table, we're going to use this probability and we're going to use this probability. And we're going to add them up. So we get 0.125 added to 0.058. So let me do that in ClassCal. So you get 0.125 added to 0.058. So this is 0.183. All right. And that's your final answer for B. Any question for B? All right. So let's go on to C. So for C, it says find the probability that the first digit for the chosen number is not a 9. So we want the probability that it's not 9. All right. So if you kind of look at the model, oops. So if we want it to be not 9, we pretty much just want all of these. So the only thing that we just want it not to be the number 9. So if we want it not to be the number 9, the easy way to do this is to get the probability of 9, and then you subtract it by 1. Because the thing is, if you remember from part A, when we add them up all of the number, it add up to 1. So that's where this 1 comes from. because we already know when we add all of the probability from 1 through 9, it should add up to 1. So since we already know it add up to 1, we could do 1 minus the 0.046, and that should give us the probability of the yellow area. So if we do that, you should get 0.954. Or if you want to write it as a percent, you should get 94.4%. All right, and that's your answer for C. Any question in regard to C? All right, so let's scroll on down. All right, so up next we're going to into something called continuous probability model. So for continuous probability model, it's when we have data set that's not discrete anymore, that is continuous. So what continuous mean that any answer, pretty much we get answers that are decimal. But what we could do, we're not limited by it has to be a whole number. We could find the area of any of this or stuff like that. So let's go ahead and let's start doing the uniform distribution. So this is the uniform distribution. When we're doing a uniform distribution, the one thing about the uniform distribution, if I were to evenly cut these up, for the uniform distribution, it says that each one of those outcome or each one of those area, as long as it covers the same area, should have the same probability. So if you look at this rectangle, I cut it up into 3 pieces. So that's telling me that this is equal to 1/3, this is equal to 1/3, this is equal to 1/3. So a uniform distribution is saying that if we have the same amount of area for each rectangular shape that we have, each one of those little rectangle or box should have the same probability as long as it covers the same amount of area. So if I divide it, each one of them has the same amount of area, each one of them should have the same probability. So for the uniform distribution, whenever we're finding the uniform distribution, we want to find an area. And the way that we find this area is by using the formula for area of a rectangle. So if you kind of remember the formula for area of a rectangle, you do the base, where we're going to say this is our base, and you're going to multiply by your height. And we're going to say this is height. So that's how we're going to find the area of a uniform distribution. We're going to find what the base is, and we're going to multiply the height. In order to find the height, we are going to use this formula over here. So the formula for height is equal to 1 divided by b minus a. So b right here will always be your highest number. A should always be your lowest number. So if you look over here, here's A and here's B. So if you kind of notice, A is the lowest number, B is the highest number. So that's how we're going to find height. We're going to do 1 divided by B, which is the highest number, and we're going to subtract that by A, which is the lowest number. All right. Any question in regard to how to find the height? Sweet. All right, so let's go ahead and let's do a problem. So for this one, says the cable company say they will be at your house to fix the cable between 9 a.m. to 3 p.m. So it says it's equally likely the cable man will arrive from 10 a.m. to 11 a.m. than if it will arrive from 2 to 3 p.m. what is the probability that the cable man come after 1 p.m. assuming X has a uniform probability distribution? All right. So the first thing that they give you that is very important, they tell you that this is a uniform probability distribution. So if they don't tell you this is a uniform probability distribution, then you're going to be doing a different, well, you're going to be doing a different model, or you're going to be doing a different approach. In order for you to know that you're going to have to do the uniform distribution, they have to tell you that this is a uniform distribution, which in this problem, they do tell us it's a uniform distribution. So since they tell us it's a uniform distribution, we know it should look something like this. So the next thing we're going to go ahead and do, we're going to go ahead and see what the earliest time that the cable man will arrive. So what time do they say is the earliest the cable man should arrive to this person's house? Cool, thanks. So yeah, so they say 9 a.m. So you put 9 a.m. over here. And what will be the latest time that the cable man will arrive? Cool, 3 p.m. Perfect, thank you. So anytime you do have time, you kind of want to convert time into hours. So what we're going to do, we're going to convert this into hours. So the hour we're going to convert it to, we're going to say that this is the hour that the person waited for. So hypothetically, let's just say the cable man arrived at exactly 9 a.m. So if the cable man arrived exactly at 9 a.m., how how much time or how many hours did the person have to wait for? Cool, zero. So we're gonna put zero in the bottom. What about if the cable guy arrived at 3 p.m.? So if the cable guy arrived at 3 p.m., how many hours did they wait for him or her? Not that many. Cool. Yeah, so for this one should be 6. Okay, if you go from 9 a.m. to 3 p.m., the time that it pretty much elapsed will be 6 hours. Because from 9 a.m., you go 9 a.m., 10 a.m., 11 a.m., 12 a.m., well, 12 p.m., 1 p.m., 2 p.m., and then 3 p.m. So it should be 6. So now 0 is going to be A, 6 is going to be my B. All right. Any question in regard to how I got 0 is A and 6 is B? All right. So if you look at it, it says, what is the probability the cable man come after 1 p.m.? So we're going to say 1 p.m. is right over here. So which side should I say if we want to find that he come after 1 p.m.? Should I say the left side or should I say the right side? All right, cool. So yeah, so you want to shade the right side because if you look at it, it says come after 1 p.m. So after 1 p.m. he could come like at 1 p.m. He could come at 2 p.m. He could come at 3 p.m. So you want to shade the right side. All right. So right now we're gonna find to see what this number is. Because we know that the person gonna come at 1 p.m. or after 1 p.m. So if the person does arrive at 1 p.m., how long do they have to, well, how long does the person have to wait for him or her? Oh yeah. So they waited 4 hours. So right here you put 4. All right. So up next, what we want to do, we're gonna find the area of this. So to be able to find the area, what we want to do, we're gonna want to find two things. We're gonna want to find the base, and we're gonna want to find the height. So right now, we're gonna find the height of this. So we're gonna go ahead and do the formula of 1 divided by b minus a, which is equal to b. If you remember, we got b to be 6. We got a to be 0. So that's 1 over 6. So that's the height of that rectangle. Any question in regard to how we got the height of that rectangle? All right. So up next, we're
Well,
gonna
where did you get 4 from?
4. So if the cable guy arrive at 1 p.m., 4 is how many hours you will have to wait for the cable guy. Because from 9 a.m. to 1 p.m., 4 hours they're gonna pass. Does it make sense where the 4 come from?
Yes, thank you.
Yeah, you're welcome. All right. So right now what we want to do, we're gonna want to find the base. So we're gonna want to find this base. So to find this base, what we have to do, we have to find the difference of these two numbers. So we have 6 and we have 4. So what's the difference between 6 and 4? 2. Cool. They put a 2 right here. All right. So up and where you go ahead and find the area. So if you remember the formula I said for the area was going to be base multiplied by height. So our base is equal to 2. Our height is equal to 1 out of 6. So if you multiply that out, you get 2 out of 6, which is equal to 1/3, which is equal to 33.3%. And that's your final answer for that one. Any question in regard to how we did this problem? All right, cool. So let's go ahead and do other problem. So for this one said, the manager of a local soft drink bottling company believes that when a new beverage dispensing machine is set to dispense 7 ounces, it in fact dispenses an amount X at a random anywhere between 6.5 all the way to 7.5 ounces inclusive. Suppose X has a uniform probability distribution. So right here, the most important thing that they tell you is that X has a uniform probability distribution. Once they tell me that, I know we're going to be using a rectangle. So they tell me the uniform distribution. All right. So for this dispensing machine, what the lowest amount that this dispensing machine would dispense? So what did it tell us would be the lowest amount that this machine would dispense at? Go 6.5. They put 6.5 here. What would be the highest amount that the machine would dispense at?
7.5.
Yeah, cool. 7.5. Thank you. All right. So what we're gonna go ahead and do, we're gonna go ahead and just find the height. So to find the height, we're gonna do 1. And just remember, this is our A, this is our B. So we do 1 divided by B, which is 7.5, minus our A, which is 6.5. If you do that, you get 1 divided by 1, which is just equal to 1. Cool. All right, so that's our height of our rectangle. So the height of our rectangle is equal to 1. Any question about how we got the height of the rectangle to be 1?
Yes. How did you get that again?
All right. So you're okay with the 7.5 and the 6.5?
Yes.
So then if you do 7.5
Oh, never mind.
minus 6.5, you should get 1. And then 1 divided by 1 will give you 1. All right.
Okay.
So
Thank you.
let's go ahead and look at the problem. So for the problem, it says, what is the probability that for a randomly selected bottle, the machine will dispense at least 6.5 ounces? So, well, 6.75 ounces. So 6.75 should be somewhere over here. And we'll put 6.75. So they say that it should dispense at least 6.75 ounces. So which side should I shade? Should I shade the left side or should I shade the right side if I want it to be at least 6.75 ounces?
The right side.
Yeah, good. So for this one, you actually want to do the right side because it says at least. Anytime you see the word at least, that means that's the minimum, but it could be higher than that value. So you actually want the right side. All right. So let's go ahead and let's find the base. So to find the base, you have to get what this number is and what this number is, and you subtract them from each other. So we know this number is 7.5. We know this is 6.75. So let's subtract them. So if we do 7.5 minus 6.75, you will actually just get what? 0.75. So for the base, we're going to put 0.75. Any question why we got the base to be 0.75? All right, so lastly, what we're going to go ahead and do, we're going to go ahead and multiply the base times the height. So the base is 0.75, the height is 1. So we're going to say area is equal to 1 multiplied by the base, which will equal to 0.75, or you could put 75%. And that's it for A. Any question in regard to A? All right, so let's do B. All right, so for this one, it's still going to be uniform distribution. It's still from 6.5 to 7.5. I still know the height is equal to 1. The only thing that's going to change is the area that we're looking for. So if you look at this one, it says, what are the probability that for a randomly selected bottle, the machine would dispense more than 7.25 ounces? So right now we're doing 7.25. So 7.25 should be somewhere over here. And if you look at it, it says more than that. So if it says more than, what side should I shade? The left side? Or should I shade the right side? Cool. So you do want to shade the right side, yeah. So what will be the base for this? So from 7.25 all the way to 7.5, what's the distance from 7.25 all the way to 7.5? Cool. So yeah, so you get 0.25. So the base is 0.25. My height is equal to 1. So if I do the area, you get 1 times 0.25, which is equal to 0.25. Or you could just say 25%. And we're done. And that will be it for this second problem for uniform distribution. Any question for that uniform distribution? All right, so let's do this last problem. So what I want you to do, I want you to practice on this problem. So I want you to find the area or the probability of this event occurring. So take a minute and try doing this one. And if you get stuck or anything, just put something on the chat or just pretty much call out and you say, I need help. And that way I could assist you with this. All right, so once you're done with the problem, yes, how you call it, answer the poll. That way we can see if you did it right or if we still need a little bit of help. All right, so far we have 5 people who have answered, so we need some more people answering this question. right, so far we got half of the class who have done this, so we'll give it another minute or so. All right, so let's share the results. So, and polling, and let's share this. Cool. All right, so based off of the poll results, which one was the winner? Cool. All right, so based off of that, we got C. So let's actually see if the people who chose C were actually correct. So for this one, for A, what should I put for the lowest number? Cool. Thank you, Leslie. What about for the highest number? What should I put for the highest number? Cool. So 30. Perfect. All right. So let's find the height of this object. So the height of this object will be, oops, 1 divided by b minus a, which is 1 divided by b, which is 30, minus a, which is 0. There you go, 1 divided by 30. So that should be the height of that. Any question in regard to how I got the height? All right. So if you look at it, you want to find the probability that it's between 10 and 15. So you put, I don't know, 10 is somewhere over here.
The
15.
work's not popping up.
No, it's not.
Mm-mm.
Okay.
It's like frozen.
Oh, here, let me just refresh it. Thank you for that. Cool. All right. So far that's the work I had. So for the height, we did 1 divided by b minus a. And that gave us 1 divided by 30 minus 0, which if you do 30 minus 0, you get 1 divided by 30. All right. So up next, we want to find the probability between 10 and 15. So we're going to say 10 is here and 15 is over here. So the keyword here is between. So when it tells between, it has to be between 10 and 15. So you want to shade this portion over here. So we should already know that the height of this is 1 over 30. But now what we have to do, we have to find what the base is over here. So for the base, you have to look at these two numbers and see what the distance from 10 to 15 is. So from 10 to 15, what's the distance?
5.
5, cool. So we put 5 over here. So now we know the base is 5. We know the height is 1 divided by 30. So if I do 5 times 1 divided by 30, that will give me 5 divided by 30. And I'm going to do 5 divided by 30 on my calculator. So 5 divided by 30. and you get 0.16666. Pretty much keep on going, or 16.6%, which indeed was C. You're talking about this one over here? If you're talking about that one will always be 1 over there. The only thing that's changing is this number in the bottom, because that number you're always going to do B minus A. So whatever B minus A is, that's the number you put in the bottom, and the number on top will always be a 1. Okay. But that's it for that uniform distribution. Any question in regard to that uniform distribution? All right, so let's scroll on down. And let's do this one. So for this last one, we're going to do a normal distribution. So for a normal distribution, this is something that we have already done, but we're kind of just reintroducing it because we're doing continuous data set. But if you remember, we have something that looked like this, which is a normal distribution. And for the number in the middle, we always put the mean. So if we look at this problem, what do they tell us the mean is?
64.3.
64.3, thank you. So you put 64.3 here. So we know our mean is 64.3. They also tell us our standard deviation. Standard deviation is equal to what?
2.7.
Yeah, 2.7, thank you. So we already know that information because that's what they give us right here, because they tell us it's a normal distribution. They tell us the mean is 64.3. They tell us standard deviation 2.7 inches. So that's all given to us. So what we want to do, if you look at it, says what is the probability that randomly chosen young women have a height between 68 and 70 inches? So here goes 68. And here goes 70. And we're going to say between. So you want to shade between those two numbers. All right. Any question in regard to that drawing so far? All right. So what we're going to do, we're going to transition over, and we're going to transition over to class calc because we're going to use class calc in order to do this problem. All right. So in class calc, if you are using class calc, you want to go right here where it says graphing and make sure that it's in graphing, not scientific. So once you're in graphing, what you want to do, the first thing you're going to go ahead and do is hit the stats button. And once you hit the stats button, you're going to go where it says distribution. So first hit stats and then select the distribution plots. All right. Any question in regard to how to go from stats to distribution plot? All right. So up next, you're going to put it the normal distribution. So you put normal distribution. So if you look at normal distribution, it's telling you that I want the mean and I want the standard deviation. So for the mean, we already know the mean is 64.3. We know standard deviation is 2.7. So for the mean, we put 64.3. For standard deviation, you put 2.7. All right. So anytime you're trying to find the probability, you always want to hit right here where it says CDF. And then it's going to ask you for the lower bound. It's also going to ask you for the upper bound. So for the lower bound, what's our lower bound for this problem? Yeah, so 68. Good. What's the upper bound for this one? Yeah, 70. So if you go from 68 to 70, if you look at it, it gives the probability that x is between 68 and 70 is equal to 0.0679 or 6.8%. And that should be your final answer for that one. So let me switch it over to so that's your final answer for that one. But if you kind of remember, we already did these type of problem like earlier in the semester. So this should be something that you should hopefully already remember. Any question on how to do this prompt using ClassCalc? All right. So for the people who are using a TI-83 or 84, I'll show you how to do it on a TI-83 or 84. That way you don't feel left out. So we'll say this. Cool. Everybody could see the TI-84. All right. So on the TI-84, you want to hit the second button. So hit second. If you look at it, it should turn into an arrow now. And then you go to VARS or VARS. You want to select the second one, which says normal CDF. If you look at mine, you first want to put the lower bound. So the lower bound 68. Next, you put the upper bound, which is 70. Then you put the mean, and then you put the standard deviation. If you don't have that little like wizard prop, like if you have it where it says normal CDF, the first number you want to put the lower bound, second number you put the upper bound, and then you put the mean, which is 64.3, and you put standard deviation, which is 2.7. You press enter, and you get your answer right here. So that's how you do it with the TI-83 or 84, depending on which one you have. All right, so let's just finish out 12.7, and then that'll be it for today. So for 12.7, pretty much it kind of recapping what we did today. So whenever we have a random variable is just your x variable. Because the x variable, we usually denote it to be any number that we're trying to find. So if you kind of look at the last one, we said x was 68 to 70. So we usually say x is our random variable, and then whatever probability we're trying to find, that's the probability we set x is equal to. And whenever we talk about probability distribution, that's the table that you have the x value and the probability for each x value, and you're kind of telling us what's the probability of each x value happening. And whenever we talk about finite random variable, that means we could count the outcome. Whenever we talk about continuous, that just means we have infinite many outcomes. So if we have a finite just means that you can actually count it, that it actually stop eventually. But for continuous, you keep going and going. So that one, it go on to infinity. All right. So that's it for 12.7. That's it for today's lecture. So let me stop the recording.